session, we are going to start our discussion on this basic commands associated with a pig. So we have in our yesterday's session we have started with the following thing. So we have started with this pig general introduction. Then we have discussed with some of the basic concepts associated in terms of shell commands. What are all the parameters that we can set in shell? Okay, pig shell commands associated, and we have discussed about some so pig installation perspective. So now in today's session we are going to discuss further about these pig commands. What are all the commands associated with this pig? So as I have already told that pig, in terms of pig has been concerned, it is very highly powerful. Okay, so it contains only around 18 to 19 set of commands. All the commands that we are going to make use of pig is coming under only 19 or 18 set of commands. That's all. So using these commands, you can do wonder with your requirement. In terms of almost all use cases associated, you can make use of the above set commands for our business logic. Apart from that, another advantage of going for pig rather than going for this highways, pig is having a community. Pig peoples is having a community. So they have UDFs. You are already aware of UDF, user defined functions. Okay. So in terms of this user defined functions, you can make use of this built-in functions. The first option is the functions are coming with this pig. That is possible. You can make use of built-in functions, or what you can do is you can make use of the functions associated with the pig community called as a piggyback. Okay, you existing building functions that is coming with this pig, or you can write your own UDF, user defined function. You can make use of any programming language as of your interest for this purpose. The third set of thing what you can do is you can make use of the pig community functions written using pig community called piggyback. So almost all sort of activity that is required is written as a function, and it is shared by the pig community peoples. Okay, so that is the most powerful thing in terms of pig has been concerned. Piggyback, third thing. Hundreds and thousands of functions are there. Almost for all activity, you can get the needed functions here. Okay, so let me discuss these built-in functions in later cases, UDF. So now what we are planning is we are going to start with the discussion on these pig commands, such as load command, store command, how to load the data, how the data structure will be like, how the pig organizes the data architecture, what is back, how the data can be stored and retrieved. Okay, so more importantly, pig uses as I already told, pig is a data flow language. It is a data flow language in which we will perform a transformation. Data will be transformed from one location, that is from one part to another part in the workflow. Okay, so we input data and the data is subjected to several transformation 1, transformation 2, up to n transformation before we got the final output. So for transforming these sort of things, we make use of the above said functions associated with this pig. Okay, so how to perform this transformation? What are all the associated command sets that we are going to make use? That's what that we are going to discuss now. Whether we have discussed about the architecture yesterday, can you, anyone please let me know? Dhanlakshmi ma'am, whether we have discussed the architecture yesterday? So here the operators associated with the pigs has been categorized as a load and, as I had told in our previous session, load and store operators, and we have the following. Whether we have discussed about these things, can anyone please? Am I audible to all? Am I audible to all? Lakshmi ma'am?
Yes.
Okay, so there was a problem in my net connection. So please, anyone kindly respond. I couldn't able to get a.
So I have a question, Mr. Raman.
Yeah, can you please let me know
So,
your identity? Is it Gandhar?
uh, yeah, this is Gandhar. So, is this a repeat session of what we went through in the morning? I mean, for you, the previous night?
No, that is the continuation of what we did in our yesterday session. Not a repeat.
Okay. Okay, because we went through the same set of commands like load, store.
That is the reason I am currently running 3 batches. I got forgotten. That is the reason why I am
Yeah,
asking. Yeah, this question.
yeah. So that's why I wanted to know
Yeah.
because we covered the basic commands like load, store, then even grouping commands as well.
Yes, we have covered this load statement, go grouping. To which extent that I had covered? That's the reason why I'm asking for.
I think you covered the basics statements and then you said that you'd be doing the practical. So I
Okay,
think
okay,
if I
okay.
mean you can check with someone else if I mean
Whether we have covered this architecture, everything, big architecture.
yeah, you can confirm with someone else in the class as well.
Please wait a while. Oh, no. Dhanlakshmi ma'am, please. As you people already aware that pig and hive serves for same purpose, but we have lot and lot of differences associated. I think so. I have listed you some differences. Here pig uses the following architecture. Okay, we have a pig. User can interact with the pig through this shell called as a grunt shell. Then when a user execute a command, the command may be a load command or store command, whatever may be the command. Whenever user issues us a command, what happens first is it will be subjected to parser. The parser will perform the activity of checking for syntax and semantics. Okay, syntax and semantics checks will be takes place here in this parser. You are aware of what is a syntax check and what is a semantics check. After that, what we did is, so this once it got cleared with the syntax and semantics, if it is perfect, then it have internal optimizers. One of the most important feature of Pig is, if you give some commands, Pig will try to optimize the command. Okay, so we have an optimizer here. What the optimizer will try to do? The optimizer will try to do some sort of optimization in terms of making the query given by you, which is written in this grunt shell, as an effective manner. So what are all the factors that it will consider in this optimization? It will consider the resource utilization factor, most prominently the resource utilization. The query should provide the needed result by minimum resource utilization. Here resource utilization covers CPU and memory RAM resource utilization. How fast the query can be executed, how minimum resources can be consumed by this query for our requirement, like all those things will be done by the optimizer. The optimizer will take care of doing all those things. Once it is perfect, once it is fine-tuned, then an execution plan will be created. That execution plan, what it will do, the execution plan will be given to the compiler here. The execution plan will be given to the compiler, and the compiler will do the rest of job of executing this particular execution plan. Okay, the compiler, after compilation, then it will fed that compiled code into the execution engine. These are all the core components associated with Pig. This execution engine in turn will invoke a map and a reduce program. Okay, what are all the things? This is your Hadoop cluster. you have data stored in this Hadoop cluster. This is your HDFS. Here, if you want to do some process on top of the data, it is allowed only by using the MapReduce programming model. Then the user return a query using this pig Latin. So this is the script the user return. After performing this sort of parsing, optimization and compilation, then we have an execution plan has been created here. The execution plan let us specify how to get the needed data, how to get the needed result. This execution plan as of in this end will be in a pig Latin statement. Okay, now it is need to be converted into the corresponding map function and reduce function. If and only if you have a map and reduce function for your script associated that is written here, you can able to access the data stored in this HDFS. That's the reason why the conversion will take place here in a converting the corresponding pig Latin script into a map and reduce function, and from here it got executed. So this is the way by which the pig will do the all sort of activity parser. Okay, and then here the parser will perform output. We call this output as a DAG output. Please make a note once this question was asked. Here DAG stands for directed acyclic. These are all interview questions. Directed acyclic graph. Which is a representation of pig statements and operators in forms of a graph manner without any looping. Okay, it will be like this. If you want further information, you can go up with the Google. What is DAG? So here it won't have any loopback statement. That's the main reason going for this. Okay, so I think so we have also discussed about the data model of pig. So here this is the way by which the architecture will function. In terms of pig, we have already discussed about what is bag, what is tuple. We are going to do the practical session now. Okay, what is bag, what is tuple, okay, what do you mean by field, what is atom? I think so everything has been discussed in our yesterday session itself. For example, if we have a employee name 1, employee name Ram and DBA 9000, we have employee number 2, employee name Arun, engineer 9500. Okay, here each and every entity we call record in our SQL. Here this record here is termed as a tuple. Okay, we call this entire row as a tuple. Tuple 1, tuple 2, like thing. Okay, so then these are all the elements: employee number, employee name, okay, job and salary. So this corresponds to fields that you already aware. Okay, these are all fields. The content of the entire row is called as a tuple. So group of rows in an ordered format is called as a bag. Okay, group of all the rows associated with the table here is called as a bag. Then what is atom? The individual value is termed as atom. It may be any value, whether it may be a DBA or it may be a salary. This value is termed as atom. So these are all some of the data structures associated with this pig. Okay, you need to aware of tuple. Or can define a tuple. Tuple is nothing but an ordered set of fields. So in pig, you have a lot of advantages in pig. Okay, so if you are creating a SQL in SQL, if you are creating an employee table, what you need to do? You want to specify the field name. You want to specify the data type. Okay. So if it is an employee name, you want to specify the field name. Also, you want to specify the size. Everything need to be specified while creating a table in SQL, or the same thing in Hive itself. You want to create a table with the following field. But in P, you can create a table employee with the field name and without data type. No issue. It won't expect any data type. You can even create a table name without the data type itself, without the field name itself. Automatically, here in this case, we will make use of a concept called as positional notation. $1, $2, $3, etc. In this manner, you can able to access the field. That is one of the most unique features of Pig. You can create a table without even specifying the column name of the table. Pig will itself will assign a column name in forms of this positional parameter. These are all the things that we are going to discuss. Okay, so this is the way by which you can create a table and you can store data on top of it. That's what for that we make use of this statement, load statement, store statement, etc., etc. That's what that we are going to discuss. Then what is back? How you define a back? You can define a back as a unordered set of tuples. Unordered set of tuples. You know what is tuple? It is an unordered set of tuples. What is unordered set of tuples? So it is not in a order. For example, the value 3 may have a Raja without any information, without the value for the job, without the value for salary. He may have another thing, a phone number. Okay. So as I already told in the initial session, the schema for Pig and schema for IO are dynamic in nature. The Pig schema is dynamic in nature. One record, first record may have 4 fields. Second record may have 40 fields. Third record may have a null field, null, nothing. Okay. So this is a possible in Pig. So that is called a back. If all the thing is having a equally sized, then we call this as a ordered set of tuple. If each and every tuple is of unequal size, we call this as a unordered set of tuple. A definition for bag is the unordered set of tuple. A collection of tuples which is not unique is termed as bag. Please make a note. Each and every tuple may have n number of fields. All the tuple does not need to have a similar number of fields. Okay. That is the thing associated. How a bag is represented. So in this Pig terminology, a bag is represented within this curly brace. Okay, these are all the records associated with the bag. Okay, if we have 1 comma RAM and if we have 1 comma, so 2 comma Arun comma engineer like thing. Okay, so you have everything represented in form of a curly brace. Curly brace, and within the curly brace, each and every individual record is represented in the following format within this brace. Okay, 1 comma RAM comma DBA comma 9000. So 2 comma Arun comma, so 2320181 like thing. So how this is identified, I will let you know. How to look after this. What are all the values that is associated with the remaining fields, that will be discussed now. Okay. This is the way by which you need to represent it. Then we have already discussed about difference relation. What do you mean by relation? Relation is nothing but a table in our SQL and Hive. We can define a relation as a bag of tuples. You know what is bag, what is tuple? Again, it is a bag of tuples. Okay, so these are all some of the things associated. So whether we have discussed these things in our previous session, data structure. Hello. Okay, so we have already discussed about, I think so, the installation part. Do you have any problem in this installation? Please let me know. I am going to start with these operators, load and store operators, and how to load data, how to store data, how to do process. Do you have any problem in your installation? Please. Anup, Balamurugan, Deepraj, Dhanlakshmi, Gandhar, Gohul, Silver Star. Have you configured Pig? Okay. Let me continue now. Okay. So here, to load the data, assume you have data in a sample.txt. Okay, which is assumed to be, the data is assumed to be under the user directory in your HDFS. So you need to load the data into the Pig. You have to load the data, you need to load the data into the Pig relation. So the command is, let me take into a credential, let me take the sample.txt the sample.text content is assumed to be contain the following information. Okay, the sample.text is assumed to be contain the following information. One is year. It is regarding of temperature in the corresponding year. Temperature and quality. So here the year 1990, the temperature recorded is 75 degrees. The quality of recording is what? In the year 1991, the temperature recorded is 76. Quality of recording is 0. In the year 1990, again the temperature recorded is 80. The quality is 2. In the year 1993, the temperature recorded is 50. The quality is 2. The year 1994, temperature recorded is 70. Quality is 1. Okay, here these are all the records. You assume you have a quality 0, 1, 2, 3. 0 is said to be of poor quality. With the recording is not a reliable recording. Whereas 1 is said to be a normal, 2 is a good quality data. Okay, let me make it 2. The normal and good quality data. This data is a poor quality. For example, data recorded in 76 is not a reliable data. We have recorded to some extent. So these are all some of the ways. If I want to load this data, this is where it assumes that you have the data as a text data, okay, which is stored in your HDFS. You want to load the data into a table. Let me make the table name. So you want to load the data into the table. How to load the data? So here you want to load the data into a table. Here the table is termed as relation. Let me make A is equal to load statement. Load which one? So under this user folder you have a data. The name of the data is assumed to be sample.text. Okay, and that you want to specify this. So load the data. The next statement is as you can specify the first field year, which is of integer, comma, the second field temperature, again which is of integer, comma, the quality, colon, which is of integer. You can load the data in this manner. After loading the data, you can find out describe A. Describe A will gives you the record structure. Okay, it will show the output year as integer, temperature of integer. If you want to display the content, you simply type dump A. It will list the content. Let me assume your sample.text. This is your sample.text content. After loaded, it will list the contents in the following manner. Okay, all the records will be listed. So at the time of creating, this is A is the name of the table. It is nothing but relation. This is the name of the table. A is the relation name. So here what we have specified, at the time of issuing this load statement, you have specified the field name and the data type. Field name 1, the corresponding data type. Field name 2, corresponding data type. Field name 3, the corresponding data type. So you can also load in the following manner. Okay, grunt A is equal to load. Okay, the following /user sample.text as directly you can specify the field year, comma, temperature, comma, quality. In this case, what data set that it will do? Okay, it doesn't specify any data type. Here the default data type will be taken care. The default data type, if you simply issue describe A in this grunt shell, if you simply issue describe A, the output will be year byte array, temperature byte array. This is the default data type assigned.
So what's the difference between this first statement and this second statement? In the second statement, we not define a data type. So if it doesn't define a data type, in pig it will accept. That is, the schema is not mandatory here. We have yesterday we have discussed the difference between a pig and a hive. In hive, the schema is mandatory. In SPL, the schema is mandatory. In pig, the schema is not mandatory. That is the meaning of this thing. You no need to even specify the field name. You can simply load the data without specifying the field name itself. Okay, no need to specify the field name. You can specify a field name for one field and you can left the field name for another field. That is also possible. For example, you can specify in this manner also. As year field, you can specify a data type for year field. You can left out the remaining field, temperature and quality, without specifying anything. That is also possible. So without doing anything, you simply just think this load user sample test into A. That is too possible. Without even defining the field name and data type also, you can able to load the data. Please make a note. These are all some of the ways by which you can able to load a data from your HDFS into a pig table.
So this is not possible in Hive, okay? So or SQL, as of I have initially told.
Okay, so now with this we can proceed with our commands that we have written. Execute. Okay. So we are going to discuss about this execute command. Execute and run command. Okay. So check this command need to be executed on a console. Execute command, you can able to execute a pig script. What is pig script? The pig script is nothing but a file with extension pig which contains the set of pig commands. Okay. Some of the allowed pig commands such as load command, store command is stored under a single file name with the extension .pig. Okay. Here, let me assume you have a data set. So employee.text. Okay, with the following information: 1 comma Ram comma again 9000, 2 comma Arun comma 9500. That we have this data set employee.text, which is assumed to be under a location /user, which is in HDFS. So here you created a file, you created a script file. Okay, a sample.pig script, a sample.pig script. What you are going to do, you are going to load this employee.text and you are going to display the result using the dump command. These are all the two commands that is assumed to be in this sample.pig script. Okay, you are going to load. What's the command for loading? The command for loading here is load statement. Okay, here let me make A is equal to, type the content in the script, load. Either you can specify the file system directory HDFS. This is also possible. Also make a note, HDFS : the IP address of the machine of your name node. Else, since we are working with a single node, you can specify the local host : so the port number 9000, which is the port number of your name node, / you can specify the user directory. Under the user directory, the name of the file is employee.txt. You can either specify a fully qualified name. This is a fully qualified name. Or else you can directly load directly /user /employee.txt. The load statement by default will look for this employee text into this Hadoop file system. Okay, here this is a local host. If you have a multiple node, here you want to specify the name node's IP address. This is the port number in which name node listens for. Okay, so either you can specify any one of the things. Here you are loading this statement, load statement. You need to specify the storage format using.
Okay, So in case of file, we have two options. If we have a file in local file system, then we use while loading the statement itself in file local. If it is in HDFS, by default we no need to specify that keyword. Whereas the big always exports the data from HDFS. Okay, the big, please make a note difference on such a difference.
Storage, as you can specify the name employee number colon integer comma employee name, you can specify colon character array char array comma and then salary you can specify colon integer. Okay, so this is the first statement. The second statement is dump here. Each and every statement it ends with semicolon. So these two lines need to be mentioned here in the sample.script. You assume your script is also in the user folder of your HDFS directory. You have yes, employee.txt in the HDFS directory of this user folder, and also you created a sample.py. The extension name is a .py file, which is also in a HDFS folder. The sample.py file contains the following two lines of information. Okay. Now, how to run this script? The command to run this script is under the grunt shell. Simply type execute. You specify the folder. Okay, you can directly specify the location, the name of the script file, sample.py. Execute command, execute the script, sample.script, and the result will be displayed here. The output will be 1, RAM, 9000, 2, Arun, 9500 will be displayed. This is the way by which you can make use of your execute command.
Okay, so I will let you know with this, these small examples, and laterly what we can do is, so we will go up with some complex real-time examples. So being it is introductory session day 1 of our peak, I am letting you know with this is some simple examples.
The table name is A. Okay, so the command you can either directly execute the command separately, or you can write this command and you can store the command under the following file name sample.py. You can run the file directly. So if you run the file, if you directly use this load and dump A, if you want to use for a second time, you want to again reuse this, you want to again type this. Instead of that, if this statement has been stored in a file, you can make use of the file any number of times. So how to run that? You can run using either run or execute, any command.
Here in this case, so you can have your file, not only here. If you have initially your file, if you have your file in your local file system, what you can do? Assume that you have your file in home/Hadoop, the same file. So if that is the case, what you need to do? Okay, the file is home/Hadoop, and then that file is employee.txt. So you want, if you want to execute in a big, the file need to be bring into HDFS. We have already discussed about these commands, I think so. To get the file from your local file system into a Hadoop file system, what's the command? The command is get command, or you can make use of another command called as copy from local. Okay, you need to execute this command, and after that, if you want to get back your result back to your local file system, you can make use of copy to local. These are all the commands that we have already discussed. Okay, I think so. All the participants aware of this command. Okay, we can use put and get for this purpose. Okay, what's the purpose of going for put and get? Put is used to do the activity of putting the data from local file system into your Hadoop file system. What the command associated here is, you can directly invoke this command in the command shell. You You can either HDFS, you can issue DFS, you can issue the command output, and you want to specify this path /home /Hadoop employee.txt. This is the source path. Then you want to specify the target path. Okay, the target path is DFS colon. You can either specify DFS or you can specify HDFS. Both of the thing works. Okay, you can do the command in any way. DFS colon, being it is a single node, you want to specify localhost colon, you want to specify the port number as 9000. So you want to specify the location where you want to store. That is, it may be user. Okay, this is the way by which you need to bring the file from your local file system into. Else, what you need to do, to move to the location cd /home /Hadoop and /Hadoop-B. If you have installed 1.2.1, move to the location and do the same command. Okay, so you can issue bin/Hadoop fs-put. Both the thing is applicable. Okay, either you can invoke HDFS DFS or move to the location where you have configured Hadoop and bin/Hadoop fs, okay, to execute a command in your HDFS part. This is what that we have discussed. You can also make a note of this command. HDFS DFS is also applicable. Please make a note. So you want to be very strong in these HDFS commands that we have discussed previously. Okay. Yes.
The name of the script. Yeah.
Please make a note.
Any one command that you can use. Each and every big job will be assigned the ID. Okay, each and every big job will be assigned the ID. To look into the ID, the command is will execute பண்ற command என்ன சொன்னேன் Linuxல shell sh ps-ef process state sh ps-ef.
Once again, this question was asked in the interview. How to identify a big job in your big grandshell? Please make a note. This question is for an architect level person.
The job name will have a particular ID. So this ID, if you want to kill, you can kill this command by using a kill command. Okay. So the command to find out the ID of your job, you simply specify sh is the shell command which runs on your Linux. Okay. ps-ef is process state. PS stands for process state. Once you got the ID, what you can do? You can simply make use of in the grunt shell kill the job ID. The job ID will be killed. Under which circumstances you want to kill a job ID? If the job is not working properly, if it is occupying time unlimitedly, in that case, if you want to explicitly close the job, you need to use kill job ID. Okay? You need to use kill job ID. So one thing that I want to let you know, so if you type integer, you can type integer up to 32 bits. If you want to store more, then you want to use a data type called as long. For example, if you want to store a number under a long integer, you simply type L. If you want to store 5.5, you simply type 5.5 F. Okay, it represents the float. Apart from the operators, we also have some arithmetic and logical operators also. You already aware comparison operators, everything that you are aware of. So in terms of arithmetic operators, addition, subtraction, multiplication, division, modulus, and condition based operators. Okay. Then in case of comparison operator, equal to, not equal to, greater than, less than, not equal to, less than, equal to, greater than, equal to. So these are all things that you are already aware of. Plus, minus, multiplication, division, modular division, equal to, if it is equal to, greater than, less than, greater than, equal to, less than, equal to. Okay, there is a unique thing associated with matches, a pattern matching. If you want to make a match for a particular pattern matching operator, you just make a note of this thing. Always you are aware of. Employee name matches. You can make a check. Raman. Okay. So here the employee name is equal to in your SQL where employee name equal to Raman. So this is the use of this matches operator, pattern matching. So not only Raman, if we have Ramanujam, if we have Sundar Raman, if you want to match all those things, what you need to do? You simply type dot star Raman. Similarly, dot star. Okay, any character after or any character before or any character after, but the string should contain noun, Raman. So all these Ramanujan, Sundar Raman, here you have a Raman and you have a Raman, everything will be listed. This is an example of pattern matching operator. This is an example of pattern matching operator. So you want to note one thing, in PIC, both the input need to be in HDFS and output also written in HDFS. So if you want to later to shift, if you have your data in a local file system, you want to move the data into this HDFS by using copy from local command. Also, if you want to move the data, output is also in HDFS. Back to local file system, you want to issue copy to local. These commands that we have already discussed. Okay, so let me start the discussion on each and every operator. The first is load operator. The syntax for load operator is you want to specify the relation name is equal to load. You want to specify the input file path. You want to specify using keyword, function, as the schema of the particular input file. Here the relation name, here you want to mention the name A is equal to load. The input file, you want to mention the HDFS directory where you have your data. Example, under user, you have sample.txt. Then using, there are 4 types of functions. One is bin storage, binary storage, to store data in binary form. Second one is JSON loader, to handle JSON data. And this is the default storage, fixed storage that we have discussed. And finally, text loader for getting an input stream of data, continuous flow of data. Okay, for holding binary data, audio, video, and images, to take care of JSON, Java Simple Object Notation log, such as server log, which is the default storage format is a fixed storage, to load a continuous streaming data. Okay, if data flows continuously, those data can be captured and loaded using a text loader. These are all the functions. Okay, so the final thing is schema. Using that we have defined a fixed storage and the default format carries a comma as a separator. As you need to specify the schema, it is not mandatory. Just specifying a schema is optional. Even though you don't specify a schema, automatically it will be, even you can close here itself. Else you can specify the schema as employee number, employee name and salary alone, field name alone. Else you can specify field name colon data type. Those things have been discussed previously.
Okay, we will have this discussion apart from that default storage, JSON storage, and binary storage, streaming storage in our use cases. Just make a note.
JSON loader is for audio and video only.
No, JSON is a different format. If you go for audio and video, that's binary storage. JSON
Oh,
is a lightweight component used for server logs like things. I will let you know with the example. No. Just make a note.
okay.
For storing audio and video, we need to go for the concept of byte array here. Byte array. Okay?
Number 9443454
We take another
2
data set and let me
and
know.
city. If we make a data set with 5 to 10 records, student name 2, Arun, age 21, phone number Chennai. Okay, you create a sample data set. Also, you create a employee data. What are all the things that we are going to work out with this data set? You create an employee data set, employee number with the employee name Ram. Again, the age of the employee, the workplace of the employee. Okay, Madurai, with the same thing, Arun, 30, Chennai, etc., etc. Okay, all our commands, we are going to work with this following thing, and the sample student data set and the employee data set only. Okay, here this student database contains the following information: student number, student name, student age, and phone number, and the location. Similarly, employee number, employee name, age of the employee, the branch or city where he is working with. Okay, branch office or city name. Let me first start with the first command.
take a note of these following commands. Okay, we will show you additional commands also. These are all basics.
Okay, let me first load this student data set. Let's assume that the student data set is under user. The name of the file is sample. Okay, the name of the file is assumed to be sample. Under the user folder, assumed to be in HDFS. The command is that we make the name of the table to be employee. Under grunt shell, under this grunt shell, you have students equal to load statement. Load, you want to specify the path. Under user, the name of the file is a sample. Then you want to specify using a function. The storage is a fixed storage. You want to specify the format of separator, comma, and as you want to define the student number, S number, colon integer, comma, the student name, S name, colon char array, comma, you want to specify the age as integer, comma, you want to specify the phone number as integer, and finally, either your phone number can be specified as an integer or a character, both the thing is allowed. And the city, either location or city, as a char array. Close and semicolon. It will load the sample data into the student. If you want to view the content, here the command is dump the name of the table, that is a student. Here the table is called as a relation. If you want to store the content of a student into your HDFS, the command is store the name of the relation student, location into, let me imagine that you want to store under user/hive folder. User hive, under the name, the same name, sample, fixed storage. Here you can define your format, either a comma format, or if you want to store it one, for example, 1 RAM 25 9443454 double. The separator you can specify your own separator. Here the separator, if you are interested to have a pipe symbol between one field and another field, if you are interested in pipe symbol, here you need to specify pipe. Here comma means here the output will be 1 comma RAM comma 25 comma 25. You can specify anything. Default comma as a separator. If you want to override the default, it is possible for you to override the default. So now we have discussed about load command. Yeah.
From this store command, is it something like a put command?
Yes, sir. So that put command, what put command will do? A put command is used to copy. What is the function of put command?
To copy from Linux to HDFS, right?
Okay. Linux to HDFS. So here what we are doing here is this load command is from HDFS into a pick table.
Okay.
This store command is from pick table into HDFS. You have data in the table, yeah. What is the name? Student.
Okay.
The name of the table. From the table, you are storing the data into the HDFS location. The name of the file is sample is the file name. The location that you get is under user hive folder of your HDFS file system. Yes? Please make a note. Then describe. You can use describe command. Okay, describe. You can describe the relation name. Describe the relation name. For example, student will let you know the details of the relation. So can I know who is caller 1? Who has joined now, please? So describe is used to describe the skill.
Request you all, once you join, please let me know your identity. I need to know who is currently attending. That's the reason, please.
Sorry, teacher, comma, student name is char array, like all this information will be listed. Okay, so this student is a name of a relation which holds the data from your HDFS. If you want to find out the logical plan, the physical plan, the logical plan, the physical plan, and map reduce execution plans, to load this particular data from HDFS into the relation, you simply type explain. Under this credential, you simply type this explain. Explain the parameter name. Okay, student. Then you also can make use of another command called as illustrate the student, which will give more detailed descriptions. What are all the plans? What are all the ways by which this action has been performed? Everything will be given a step by step with the appropriate example. Okay, I will share you some sample data set. You can make use of the same data set. Hmm? Hmm. இது TCS document. நான் உங்களுக்கு வெறும் இது மட்டும் அனுப்பிச்சிருக்கேன் ஃபுல்லாக நான் சொல்லி கொடுத்துருக்கேன். நான் ஒருத்தர் பண்ணோம் இல்லையா, இது எல்லாத்தையும் கொடுத்துருக்கேன். டிசிஎஸ்னு வராததெல்லாம் நான் கொடுத்துருக்கேன். டிசிஎஸ்னு வந்துச்சுன்னா கொடுக்கக்கூடாது. I will share you for our example. I will share you this data set. To create a data set of this example, we are going to discuss for grouping and subgrouping, all those things. We are going to make use of the same data set. Okay. You create, if you can, you create, or I will share this data set. So what's the reason began? We are going to, if you want to make a group based upon this age, you want to make a group based upon this location. So all the students belonging to Chennai will be grouped. Students with this age group 21, with age group 22, 23 will be grouped. So we want to go by the same example. Okay. The next command is group by command. Here the group by command, what it will do is used to group the data into one or more relations. Okay. So here we are going to group the relation based upon a particular age. Okay. So if you type group the relation, student relation by age, then what will be the output? So first the age will be taken and all the students with this corresponding age will be grouped together. Example, the unique value is age 21 and age 22. Here in this we have age 21 and age 22. Okay, 21 Rajiv Reddy and Preeti Agarwal is of age 21. Preeti Agarwal and Rajiv Reddy is of age 21. Rajesh Khanna and Siddharth is of age 22. 22 Rajesh Khanna and Siddharth is of age 22. All these record Komal Nayak and Bharat Nambiar is of age 24. Okay, all the information, the Bharat Nambiar and Komal will be displayed. Okay, so if you group the data by age and all the students will be grouped according to the age. If I want to group further, so those students not only by age, also by the city, then I want to specify age comma city. You can group the table not only by a single field. You can group the table by multiple fields also. Here in this case, example 1, group the student by using a single field. Example 2, group the student using this age and city field. Okay, this is the output. So if you want to group all the data, okay, if you want to group the entire thing, then you need to use all statement. This statement will be laterally explained because you can't able to grasp anything from this all statement as of now. So you just make a note of this two, group by age and more than by multiple fields, age and city. Okay, this is the way by which we can use a group statement. Group data is the name of the new. This is a table name. You want to be very careful. Group data is a table name. It's nothing but a new relation name. This is your old relation name. Okay, the student is your old relation name. The content of this old relation is subjected to a transformation, and based upon this condition, that is a group is by condition by the age field, and the content has been stored under a new relation name group underscore data. So we have already discussed group operator is used to group the data into one or more relations. In this example, we have grouped the data of a student relation into another relation called as group data or group data 1 or group data 2.
Make a note of all these individual commands. So in our use cases, we will discuss how to club and how to write a complete fixed code.
What schema it will be having? It will be having the same schema as student?
Yes, the same schema. If you perform a discrete, we can find out the schema. Here this is a bag. This is anything which is enclosed within this open and closed brace. Flower brace has been termed as bag. It will simply say the schema is age which is of integer, comma, it specifies a bag entry. If you simply describe group underscore data, it will show the following input. The schema won't modify. You are making a transformation from one table into another table. So here the group operator works with one relation. So there is another operator called as a co-group which works on more than one relation. For example, the next command that we are going to discuss is let you know. You have two tables. One is a student table, another one is a employee data set. So here what we did, we have grouped this student data set based upon this age. If you want a new entry, a new table, a new relation which contains information from the both relations, not only from a student, if you are interested in grouping based upon age, this from the student database as well as from the employee database. Okay, this is your student data set and this is your employee data set based upon age. For now, you have 21 age 21 for Rajiv Reddy and you have age for Preeti, and from the sample data set you have age 21. Let me check anyone is having age 21. If you have, then it will be combined. No. Now you have a new another entry, age 22. Age 22 for this is Siddharth, and you have age 22 for Rajesh Khanna. These two records from this student, and you have Robin age 22 and Maggie age 22. All the four records will be stored if you use co-group. So the command for using this co-group is used to group based upon more than one relation. One is a student relation, another one is employee relation. Okay, it will form a group based upon some common condition. If the condition is the age field equivalent to 21 or age field equivalent to 22. Based upon that, we are going to make a group. The group operator works with only one data set, either a student data set or with the employee data set. We can group. We want to combine the records from both these data set. You need to go for an operator called as co-group. Please make a note. Array format. This is the example of co-group. Here the command is co-group. Okay, this is the new relation name. Co-group data is the new relation name. You are going to co-group the first table student by age, comma employee by age. The output will be contained of it will be the 21, age 22, age 23, and age 24. So all the records. If you don't have a record on one particular, it will have a null value for that. So you are going to get information from this student as well as from employee based upon the condition similar age. Please make it.
We can go for a break and be there at now the time is 9:40. We can have a break and be there at 9:45. Sorry, 9:50. We can start our discussion further. Yes, Ganga, what is your question? Gandhar, am I audible? Gandhar, I couldn't hear you. Can you please talk little bit louder? Gandhar?
Now those things has been shown to you lab.
I will execute the command, sir, now.
Yeah. Now this
Store statement.
the load statement loads the data, big data, which is in your home Hadoop. The data file is sample.txt. Here you are using the big storage tab as the storage parameter. So also you specify /tab is there. Please wait. Please wait over. Abid, you continue. Abid, you please continue.
Yes, sir. Here, next statement will be a store statement. I'll just copy and paste this thing because the table has already been loaded with the data. Now let's see how it actually stores things.
Okay, I will take care of.
Already.
Next, this is the load statement. Here is loading the table. Highlight that command. Here is the data set. He is going to show you the data set.
So I'll store the table created, sir. This command actually. Here.
Abid, you please wait. First you load the statement, highlight the load statement.
Yes, sir, sure.
Yeah.
Do step by step, Abid.
Highlight the load statement. Yes, okay. So here, the sample.txt that is shown to you contains 5 fields. The employee name, employee number, the salary field along, 4 fields, the salary along with the job name. Here it was placed in the local file system, and the separator being it is a tab as a separator, you are using this keyword using big storage. It is an optional thing, okay, even if you don't specify, and if it is a defaulted to tab as a separator, you don't need to specify here. If you
Please make a note here. I have started a big as a local. Okay, that is the reason why I can. This is big -x local. That is the reason why I can specify my path in the local file system. If I have invoked the big under a distributor mode, I need my data stored in HDFS. Please make a note.
recognizes the ID with integer data type, the second field with the name as character array, the third field with the salary with integer, and fourth one designation as the character array. Okay. So after that the data has been loaded. What he is doing is doing the second command. Store the data. Now where the data is? Data has been loaded from the sample.txt, which is in an unformatted manner, into a relation. The relation name here is a sample. This is the relation name. Okay. The relation name is a sample here. Sam is the name of the relation. Now what he is doing by using the store command, the data which is stored in the relation has been stored back to the local file system, that is home Hadoop, under the big. Okay, here this is the name of the file. Big is the name of the file under which you have the data. At the time of writing the data from the relation sample into this storage, that is Linux storage, and the separator he defined is using a pipe as a separator. The original data from the sample.txt contained tab as a separator. It got loaded into the SAM, and under the SAM, it now becomes a structured data. Then you can apply any query on top of it. Then to demonstrate this store command from the SAM, he had loaded back to the local file system under the name with the separator as a big as a separator. Okay. So now you are going to display where here you just issue the command SAM, dump SAM. Clear the screen. It is a best practice to clear the screen before proceeding with the subsequent commands, so that it won't be confusing for the audience. Okay, so here it will show the message successfully stored records in home Hadoop pig. Okay. Now the data from sample.txt has been loaded into SAM. Now to display the content of the SAM, the command is dump, D-U-M-P, dump space SAM. It will invoke the corresponding map and reduce, and it will display the result. Okay, the data, you just make a look. The original data, which is in tab separated format, once you load it into the pig relation, it will by default a comma separated format. You can query the data here. If you are looking for how many records are there, so 1, 2, 3, 4, 5 records. Filter, SAM by, what is the field that you have defined? 4000. Filter, SAM, that table name, by. Condition, what is the name of the field? Salary. So to look into the name of the field, no issue, describe SAM. Describe SAM. Abid, type here itself, type in the grand cell itself, Abid, describe SAM, colon, semicolon. Each and every command need to end with a semicolon. Okay, you can find the field name is salary. So what you need to do? So you want to apply a transformation, and the transformation need to be stored under the separate relation. You give a SAM1, relation name as SAM1. SAM1 is equal to filter, the original relation SAM by salary space greater than 40,000. So how many records are having 40,000? Only 2 records, 40,000. Semicolon. Now dump SAM, what is the command? Filter. Filter use capital letter. Filter use capital letter. All caps letter. SAM1 is equal to, you just copy paste the command that you have practiced, that's all. You no need to struggle. Already you use the store statement to store the SAM into the home bag, and you just show the filter SAM by is giving the condition equal to condition. So something will be case sensitive. Abid, you just cut and paste, Abid. No need to struggle. You just make a cut and paste. If you are doing some typing, it will be time consuming. Also, if you left out some keywords in caps or small, it will lead to error. Clear? Okay. So here, by applying this filter condition, please wait. The filter condition we have discussed is used to retrieve the result based upon certain constraint. Here the predicate is whose salary is out of these 5 records we have only 2 records whose salary is equivalent to 45,000. Those records alone will be taken and it will need to be stored under another name. The name given to the new relation is after applying this transformation to the original SAM, then the retrieved result they will be stored under filter underscore SAM, FLTER underscore SAM. To show the content, dump filter underscore SAM. It will show you only 2 records. Enter. Okay, you can highlight those records. Only those records which is satisfying the following constraint. Okay, 45,000. You can also apply a less than operator. You repeat the command with less than operator. Filter underscore SAM1. Let me make it under SAM1. Yes, filter. Okay, to by salary less than 45,000. Okay, now excluding these 2, remaining 3 records need to be stored under filter SAM. Enter. So dump filter SAM. The first one is FLTER. The new name is filter underscore SAM. So that is the reason why I had asked it to go for SAM1, SAM2. It will be easy. Okay, yes, enter. Filter underscore SAM will contain the records whose salary is less than 45,000. So the remaining 3 records, out of the 5 records, 3 records will be listed. Okay, 40,000 and 30,000 salary will be listed. So this is the example which helps us in letting you know how to load the data and how to store the data back and how to apply filter. Okay, you continue Abhi. Continue with others. You just make a group. Yeah, you are having how many groups? How many data? Filter SAM. How many records? Okay, group by salary. Let me make it group by salary. Okay, type this command. Okay. Abhi, continue. So let me group based upon salary. So here dump SAM salary means, so it will group. We have 3 groups. One group with 45,000 salary, another group with 40,000 salary 2 member, and another third group with 30,000 salary.
Please kindly bear the delay, being it is connected to another machine, Abit machine, we are facing with this delay.
If you are working with a huge cluster, வந்துடுறா கரெக்டாக 12 மணிக்கு போயிடுவோம். 11:45 நான் ரெடியாக இருக்கேன். 11:45 வந்து ஓகே, 11:45 வந்து நண்பு. சரி சரி, வீட்டில் இருக்கேன். Here you can find the records have been organized based upon the group. If you okay, the group with the 30,000 contain 1 record. The group with 40,000 contain 2 records, and group with 45,000 contain 2 records. Okay, this is the use of a group. You can apply a group to group the data based upon certain field name. Yes, continue with the other. Abhi, continue with the next command.
சார் இப்போ ஒன்லி குரூப் பை salary 45,000 மட்டும் கொடுக்க முடியுமா?
Group by, hello, Any question?
அதாவது குரூப் பை சேலரி வந்து மொத்தமா கொடுக்காம வெறும் 45,000 மட்டும் கொடுக்க முடியுது. 45,000ல இருக்கவங்க மட்டும் குரூப் பண்ணுவோம்.
Equal to.
So you load this sample data set. Okay, for this command, we are going to load this another sample data set. So to work with this distinct operators under the associated operators. So we are going to load the data set. The data set is tn-data.txt. The data set will be shared to you along with the document. You just make a copy. Here we are going to load the data set which is stored under home Hadoop under the big data folder. The name of the data file is tn-data.txt. Here the default here is just make a difference. The data tn-data.txt is a separator, fields are separated using comma as a separator. In our initial case it was a tab as a separator. So being it is a tab as a separator, you no need to specify using big storage. Please have it, please. So that here you are using comma as a separator, therefore it need to be explicitly specified by using this is your data. You find the data set separated using comma as a separator. Therefore you want to use the following statement. Go to query. Using fixed storage is mandatory. Then you are defining as the first as ID, second name, third as city, fourth as street, and fifth as Gmail. Yes. Now we are going to apply this distinct. Okay, if we are going to apply this distinct, enter. Dump distinct and all the duplicates will be eliminated. We have intentionally created some duplicate records. To overcome those duplication, dump distinct Tamil Nadu. Each and every command will invoke a corresponding MapReduce. So here you can find out if the duplicate values have been eliminated. You just show the data set of it without this duplicate. This is the data set. You can find the records duplicated for each Abid 2 times, Raman 2 times, Amir 2 times, Abdul 2 times, and Naresh 1 time. So all this duplication has been eliminated and it will be resulted as a single value using this distinct. Okay. Yes, next. Next command. Okay, next we have demonstrated the example of distinct. The next one, ranking. Abid, please let me know which command that you are going to exhibit. Okay, rank. So you can find please the rank command. What is the use of rank command? So there are two options. One is rank, another one, and here we are going to demonstrate the listing based upon this descending, okay, ascending or descending, that is the order by class. Under that order by class, we make use of, please wait a bit, please wait. Under the order by class, while I am talking, you no need to go far, okay, just wait. The order by class contains two things. One is rank, another one is rank along with tens. Let me differentiate these two things. What's the use of this rank operator? It is used to list the top n records based upon certain order, whether it may be an ascending order or it may be a descending order. Here, based upon this salary, it has been listed. Okay, you can find the record listed in a descending order, starting with the highest salary with the Global Manisha 45,000, followed with Mastan and Kiran 40, followed with Kranti 30,000. While performing order by based upon descending, the rank, what it will do, it will list the unique ID based the rank number. You can find being these two records is similar, one and one, there is no second rank. Therefore, with excluding the second rank, the next it is skipped, the second is skipped, and the third rank has been listed. Being these two records containing 40,000, there is no fourth rank. So if you specify rank and if both the records are unique, then that intermediate rank will be skipped if you use rank alone. To overcome from these difficulties, what you need to do is, if you use a dense keyword along with this rank, then it will be ranked based upon the corresponding field in a descending order. Also, the rank will be a sequential rank. Okay, first two persons, first two guys with two rank, first rank. The second two persons with the two second ranks, like this. That is the difference between having rank alone and rank with tens. Exhibit this. So for that we are making use of another data set.
Sir, no separate data set, sir.
Okay, the same data
Sample
set.
table is all.
Yeah. The rank is going to be applied on the sum. So you want to query the top 5 records, top 10 records based upon certain conditions, in sense you want to have this rank. All the functions that we are discussing individually will be clubbed in our use case. Yes, Abid, continue. So being the laptop is at a different location and myself, my system is different location, a little bit slow. Abid? Please bear the slowness. Abid, are you with us? Yes. Abid, what's the problem? Continue. Okay, this is the data set which demonstrated the distinct. Now we are going to demonstrate this rank.
I will share you all the sample data sets. You can work with the real data sets. Okay. So these are all practical examples. Once you are aware these things, then only if we go for real-time use cases, how to make use of these things will be revealed. That's the reason why I am going for with this sample, small data sets. From the coming session, we will try to work with our system itself. Being my system got corrupted, I need to get the help of Habit. That's the reason why there is a miscommunication and delay. Not synced. Habit, you please follow.
Coming forth and back. Let me make another presenter. Okay, we can continue with our discussion. Okay.
The connection got terminated. We will continue with our discussion. Okay, once the connection is ready, we can back.
We can continue with the practicals. Okay, we have so far discussed how to load and how to perform a store operation, how to perform a dump operation, how to perform a filter operation, how to make use of the remaining thing. Okay. Abhi,
So here are all the things that we have discussed in today's session. Is a basic overview. We will go further. I will share the data set. So you can work with the data set so that we can continue the remaining thing in next class. Okay, it is already time for another batch. So we can conclude today. Abhit, you just complete this task so that we can conclude today. Since already 10:30, I need to start another session at 10:45.
need to be stored on a separate resolution name. Okay, dump rank underscore sum.
This is the associated.
So it is recommended to go for minimum of 4 GB of RAM for your practicals. If you have 2 GB or 3 GB, it will be time consuming. Even with the 8 GB of RAM, with an i7, a new machine, it took this much of time. Okay, you can find it is listed with the following rank: 2 first rank, 2 third rank by skipping the second and fourth rank. So if you club this rank along with remove this sequence to attain the original sequence 1, 2, 3, then you want to follow this command, execute the command. You want to go for an option called as dense option. Okay, rank with dense, rank sum by salary, then salary is going to be in descending field, then dense will eliminate the abortion issues that we have faced with this rank. Okay, enter. So let me make the new relation as rank underscore samp1, and we can find 1, 1, 2, 2 and 3 if you make use of this dense dump rank underscore samp1. If you have 16 GB RAM with i7, it will be little bit more efficient. You can find 1, 1, 2, 2 and 3. This is the use of this tens. Yes, the next command. So okay, we have discussed about this join and split operators. So the split operator is used to split a relation into two or more sub-relations. We are having SAM. Here what we are going to do, we are going to split this relation into SAM1 and SAM2. If the salary is greater than 4,000, then those data will be stored under a SAM1. And if salary is less than 40,000 or equal to 40,000, those records will be stored under the SAM2. So this is the way by which, by using a single statement, you can, based upon certain conditions, the split condition here is salary field greater than 40,000 and salary field less than 40,000. You can also make it with some other condition as of your requirement. This examples deals with this salary condition, which will create two physical relations, SAM1 and SAM2, once this is executed. The SAM1 will contain only those records satisfying greater than 40. We have only two records, 45,000, and the remaining three records, 2 40,000 and 1 30,000, will be stored in the SAM2. Execute this command. Split is one command. We have discussed about this split and union. Union is to join two or more than two relation into a single relation. Split is used to split a single relation into multiple relations. Split SAM into SAM1 if salary greater than 40,000, comma SAM2 if salary less than 40,000.
This is one of the unique command found in P, which you couldn't found in SQL.
Now you have this SAM1 and SAM2. Dump SAM1. Why this dump command alone takes this much of time? The split command, all other command immediately executed. The dump command alone this much of time only, as told. Either if you issue a store or issue a dump, then only all the execution will be executed. Until then, only the plan alone will be created. If you issue this split command, how to split this SAM into SAM1 and SAM2, that logical execution plan alone will be created. It won't be impacted. It won't really create two separate SAM1 and SAM2 relation. Though SAM1 and SAM2 relation has been created if and only if you issue this dump or store. That is the reason why a dump command will let you execute all the execution plan, and all that execution will be listed, and the result took some time to execute. Okay? Yes, semicolon, dump SAM1. Here only the execution starts. Yeah, corresponding map, you can find the records satisfying this condition. Only two records. Dump SAM2 will result in 40,000 and 30,000. The remaining three records has been stored under SAM2. Okay, yes. So this is the way, by using a split, you can able to split the tables based upon certain conditions. Next.
So with this, we can conclude today's session. What we have discussed so far. Okay. So here I will share you the videos what we did so far along with the documents. We try with the videos before coming up for the next session. Next session we will be having your next session on coming Friday. Okay, so Friday, and once again on Saturday and Sunday we will be having the subsequent sessions. By the end of next Sunday, we can complete our pig and also hive. Okay, so This is the agenda for the next 3 days. In Saturday and Sunday, we have our session Saturday evening and Sunday morning. And in Friday, we have a session at Friday night around, we start the session a little bit earlier, Friday night around 9 p.m. to 11 p.m. We can have the session in the following time. Okay, I will let you know the session timing. I will share you the coming Friday. We will be having a session at 9 p.m. IST, or we can start up with 9:30 p.m. IST, end up with 1.5 hour session, 11 p.m. or 10:30. So at what time? 1.5 hours. In this, we can continue the remaining commands of ping. Probably the commands will be over, and by Saturday we can have our session on Saturday morning and also on Sunday morning. On Saturday we have a session at 8 a.m. Sorry, we can start with 9 a.m. to 11 a.m. and Sunday too we can have the session timing at 9 a.m. to 11 a.m. Okay. Sunday session probably, so I am leaving for training for Bangalore. So if I am planning for a flight at 1:30 noon, if I couldn't get that flight, I need to catch a flight for around 10 to 10:30. If that is the case, our Sunday session may be postponed. Okay, so these are all fixed timings, Friday and Saturday. Sunday, I will let you know. This is the agenda. So we can complete our peak and the remaining part of the hive within this aborted scheduled session. I will share the video and I will share you the document. You go through the document. What are all the documents that I am going to share is going to be discussed on Friday. If you have already practiced, we can skip those things and we can straight away go to hive. It is up to your choice. Okay. So thanks a lot. If you have any doubt in today's session, please let me know before winding up today's session. I want to start another session at 10:45. Anu,
Sir, are you sending a large data? Sir, Gokul here. Are you sending today the large data sets to practice?
Okay. Do you have any doubt? Please let me know.
Sir, Gokul here, sir.